So I hope all of you are really excited to start your internship in data science. Um, so just before we start, I think let's take a small review. So for how many of you is it your first time with data science? As in, if you're having a little knowledge about it, or is it is your absolutely first time? For whoever it is your first time, you can raise your hands. Okay, nice. I see a lot of hands up. So I think it's a new domain that all of you are going to get into, and that'll be fun. So I hope all of you are also very excited. Are you guys familiar with a programming language, or this is the first time you're going to do any type of programming? If it's your first time with a programming language itself, then please raise your hand. Otherwise, you can like put it down. Okay, so I think all of you are have had some experience with the programming language before, I see. Okay, so for how many of you is it your first time with Python? Okay, so for two of you, I see. Okay, okay, nice. So for some of you, it's your first time with Python, but you've probably had experience with another programming language like C or Java or something like that. That's nice. I'll anyway share my screen and we can start off with our introduction to data science. I hope my screen is visible to all of you. You can put in the chat section if it is visible to all of you. Yeah, okay. Thank you. Okay. So firstly, we're going to start with the introduction to data science. During this, we will basically try to understand what data science is and what is the power of this and what type of problems we can solve with this approach, right? So we should basically understand what do you mean by data science, and there is so much buzz around this word, and everybody is like, it's a word that people not just in the technological domain talk about. Everybody talks about it, so let's try to understand what the hype is all about, right? Yeah. So some months ago, I remember that my mom was complaining about how she was getting a lot of these messages and notifications about so many jobs in data science and even machine learning. And she would say that I've not subscribed for any newsletter or updates. Then why am I being spammed with all this? Right. So frankly speaking, even I was very surprised on why she was receiving so many updates. But then later, I realized that she had logged into her account on my laptop's browser. So she was getting updates regarding what I was looking for, right? So now many of you might think that this is happening because of cookies that we have in our browsers, right? So cookies are essentially these small things that help you remember, help the browser remember and the server remember the user, right? So whom you're interacting with, you're trying to keep track of that, because generally we use HTTP protocol, and that is a stateless protocol. So you don't, if the same browser is having, let's say, 5 to 10 hits on the server, it doesn't understand, or it doesn't really keep track of whether it's the same device or the same client that is hitting again and again, right? So because that's what you mean by stateless, right? So basically you take assistance of the cookie to remember the user and understand. And another thing that they also use is sessions. So anyway, so we can remember the user and work on with it, right? So cookies is one thing, but then cookies just helps you in remembering the user. It does not help you in understanding what is the interest of a user and how you could give suggestions about the same thing, right? So this only happens because a subset of data science, which is machine learning, right? So a machine learning algorithm is running in the back end. So because of which because of which is all of this possible, right? So also we have noticed that there is a drastic increase in opportunities regarding this in the past few years, right? So I've even heard my friends who are not even in computer science background or even engineering background who also talk about it, right? So I have friends from fields like, tourism department, financial side, all of them are also talking about this. So when they are people who are not even related to technological background and they have idea about data science, machine learning, artificial intelligence, and all of these. So for us, being engineering and technical students, I think it's crucial that we should have a little understanding, even if not the best, of what exactly data science is, right? So that is exactly what we'll try to do today. Okay, so the agenda for today is to understand our internship structure, understand what is data science and the various subsets, and basically how what is the data science comprising of. And let's try look into some of the common myths that people have with with respect to this topic, and then we'll also see different types of machine learning, and then we'll prepare our laptop for the future sessions. Okay, so our internship will basically have two phases. In the first phase, we'll look into the basics of Python. Then we'll understand some principles of statistics, and then we'll look into uh, data wrangling, data storytelling. We'll look into these concepts. Then we'll look into a subset of machine learning, which is classification problems. And then finally, we'll look into what deep neural networks are and how exactly are they different and what is special about them. So that will be what we will cover off towards the end. And this will be the first 20 days. And the next 10 days, you will have time to build your project based on everything that you have learned in the first 20 days, right? So first, let's try to understand what is data science, right? So this is a definition that I picked up from Wikipedia, where they say that it's an interdisciplinary field that uses scientific methods, processes, and algorithms to extract knowledge and insights from noisy, structured, and unstructured data and apply this knowledge and actionable insights from data across a broad range of application domains, right? So it's a very huge definition. And so let's try to break it into smaller parts so that we actually understand and make sense out of this, right? So basically what they're saying is it's an interdisciplinary field. So it is a combination of multiple processes and ways of doing things, right? And the main idea is that you want to extract some type of knowledge, you want to take some type of decision, try to gather data, and based on this data you want to basically create some valuable insights, right? This is what we want to do. And for this we can be using data that can be there from any source, right? So like there are many sources of data, and all of these sources produce data in different ways, right? So not necessarily that all the data that we have will be in the form of tables, or it's not always like a fixed database, right? So we have structured, unstructured data, and a lot of noise in the data as well, right? There'll be a lot of missing values in the data that we collect, and there'll be a lot of redundant information, there'll be a lot of wrong information also. So all of that needs to be cleared and all of that. And from this data, whatever knowledge we are gaining, so this knowledge should help us in getting some insights, taking some decisions on various different domains, right? So this concept can be applied on literally any business application, right? So this is a Venn diagram that shows what data science actually comprises of. So we have three big circles here. One, the mathematics, then we have computer science and domain expertise. So we have each of these three things, and data science is actually a mixture of all of them, right? So essentially, when you use mathematics and the expertise of a domain is what rises in statistical research. So you use mathematical modeling and information with the data that you have collected, right? Based on and with your domain knowledge. If you're working on something with respect to, let's say, a nuclear power plant, right? You're having data based on that. You need to have some knowledge about the different parameters that set of people use, right? So you need to have some knowledge about that, and you need to have the knowledge of mathematics, which basically helps you in making sense out of this data. And um, a lot of things are built on mathematical models, right? Which basically statistics. So all of that will help you in making decisions. So that is something which is statistical research. Next, we have computer science and mathematics together, which form machine learning. So machine learning is basically a type of programming, you can say. It's a type of methodology that we use to solve problems, which is extensively built on probability, linear algebra, calculus. All of these are play a very crucial and important role in building all of these algorithms, right? So a mixture of those two, rises in machine learning. And data processing is when you have this huge set of data, right? We want to make sense out of this data. And like I said, you have a lot of noise in the data and all of that. So we need to make it ready uh, for us to use it in any place, right? You cannot directly, let's say there is a textbook. Now there's a lot of content in the textbook. This is not in a tabular format, right? But we need to extract information out of this. So there should be some way in which we will summarize and concise this information, not necessarily just a textbook. Not, there is data available in many ways. Like now IoT is, used a lot. So all of these sensors are generating a lot of data, and they're generating, 4 5 GB of data just in like 2 3 minutes, right? So when there is so much data available, we need to compress it and without losing any important information, and still take decisions based on that. So data processing and helps in that. So now data science is actually a mixture of all of these. We'll try to understand what each of these parts are individually, right? So first of all, statistical research, right? So it is a discipline that concerns with collecting, organizing, analyzing, and interpreting from data, right? So basically, it is the science of learning from data, right? That is what statistics is. And this knowledge will help you use proper methods to collect data, and even understand the correctness of the analysis, and effectively use and present these results, right? So it is very crucial behind how it's a very crucial process behind how we make discoveries in science, right? Yeah. So until now, if any of you are you guys having any doubts? Yeah, okay. Are data science and machine learning two different fields? Is data science a vast subject? Yeah, data science is definitely a very vast subject. Like I said, like it is having so many subsets, right? It is a mixture of all of them. And data science and machine learning, I don't think there's like a hard boundary between them. Like machine learning is a subset of data science, right? When you're trying to implement data science, you can do, one of the ways to also do it is with machine learning. They're not completely different, they're very much interrelated. Does that answer your doubt, Reshma? Okay. Yeah. So let's look at some of the applications of where statistics is used in so many industries, and how all of these are things that we would have, encountered some point in our life, right? So all of us watch weather forecasting, right? We want to know, I mean, I don't think we do it generally every day. We don't look for what is going to happen, but weather prediction is really important, right? It is a very good indicator of the situation that might arise and help us be prepared for it. So how do you think that they predict all of this? So they have a lot of computer models that are actually built on statistical components, and these models compare the prior weather data and with the current weather, and then they're able to predict about the future, right? So this is using statistical models behind. Also, statistics is mostly used by researcher. I'm sure this all of you will know, right? So they use various statistical skills to collect relevant data, and it always and it's that helps us in saving the loss of money. Like you can generate a lot of data using statistics rather than spending a lot of time in collecting all of this data. So you're helping in that way. And also from insurance. Now everybody has some kind of insurance, right? Whether it's a medical insurance or a house insurance or any other type of thing. So basically, based on an individual's application, some businesses they use statistical methods to calculate the risk of giving an insurance to this person, right? So all of these decisions are also taken using statistical methods. And also in, let's say, the financial market, right? So there also statistic plays a really huge role, right? So there you understand the key reason and idea behind traders and businessmen in understanding where they'll invest their money is by looking at what stock is going down or up, to understand the and to be able to predict whether there is going to be a growth in the market, right? So there again statistics is used. And it also plays like a very big role in medical field. Yeah, so like any drugs that's been prescribed by, so that the scientist actually shows statistically valid rate of effectiveness. If that is not proved, then a drug is not released to the market, right? So statistics is behind all the study of medical data that is there. In fact, even when doctors are trying to predict whether there is a disease, that is also based on statistical concepts, right? So like there's a survey that shows that around 75 to 80 people have cancer and they're not able to find the reason. But when the statistics become involved, then you can have a better idea of how the cancer may affect the body, or is smoking actually the major reason for it, right? So all of these type of analysis to understand the root cause, to understand the existence of a disease, to understand what medicines can be used, right? So literally in every aspect of medical industry, statistics plays a very huge role. Also the news channel and the government in general, right? So like news reporters make prediction of who the winner of the elections are going to be. All of this is based on political campaign, and here again statistics also play a strong role to understand and analyze which government might win, right? So and also statistic data also allows us to collect all of this information from all over the world. The internet is very device, and that helps us to collect this information very easily. And the fundamental idea behind the internet is based on statistics and mathematical concepts itself, right? Yeah. So that is our discussion with respect to statistical research and how it is used in so many places, like every other aspect of your life. It is used in some way, right? Even in even in the IT industry, statistics is used extensively. Anyway, so the next thing that we have is data processing, right? So in case of data processing, you have collected your data and you need to manipulate this data to the way your models might require, or you need to do a lot of cleaning first of all. In fact, cleaning is what we take a lot more time than building models. And data processing, people don't talk about it that much in college level, but that is a really really important aspect in the data science life cycle, right? It is converting one form of data to another form of data that makes more sense and that is more related to what we are doing. Okay. Any doubts so far? If any of you are having any doubts, you can put it in the chat section. See, when I collect data, when I collect this random data, let's say you go to some office in the government, right? Some government office, right? They have collected all of this data from many years. And here what happens is many a times they just fill random data into it because they don't know the correct value, or they just leave it unfilled, right? And or they might there might be some data which is really peculiar and different, so we call this as outliers. So a lot of such data will be added in your data set, correct? So you need to remove all of this. Now if you have a lot of missing information in between, how will you be able to make sense out of that row, right? So if you're collecting information about one person, you need to have all type of information, and it has to be reliable information. So you need to understand how good the data is. The more better the data is, the more better analysis we'll be able to do, right? So that is why we need um, a good data. And it's not normal to have data that is going to be that clean, because when people are collecting this data, it's usually done, it is not done with the idea that it will be of use later, right? It might be of use for them at that point, so they'll only collect that much information. So it is very restricted, and attention is not given as much. And in fact, even when you collect a lot of data through web scraping, so a lot of unnecessary data is also there. So we need to process this data to only the necessary parts. So that is what is data cleaning. Does this? Okay. So can we move to the next part? Okay, I think we'll move forward. Yeah. So now we have understood data processing. We have understood statistical research. Next, what is machine learning, right? So many people talk about it, but what exactly is it? So this is again, all of the definitions I've taken it up from Wikipedia, right? They give very crisp and good definitions, but we will look into it in more depth and try to understand what they're telling, right? So they say that machine learning is the study of computer algorithms that basically improve automatically through experience, correct? So this is what we understand from machine learning. Now, the definition seems very straightforward and easy, but how is it actually different from the type of programming that we have been doing all this time? What is so different about it? And what do you mean by improve automatically through experience, right? This is something that we need to understand. So let's see what is the difference between our traditional programming and machine learning. That will help us understand how, because when you compare it with something that you already know, that'll help you get a better understanding on what it is. Right. So essentially, if all of you have done some type of programming, right, most of you have. So what exactly happens in a program, right? We write the entire code. We know a way, or there is a way in which we expect an input to be received from the user or another file, any form, right? So we know the type of input that we'll receive, and we write a program such that it caters to the input data, and we do whatever processing needs to be done, because we know in our mind, we know what is the expected result. So we are basically connecting the input to the output through a program. This is how traditional programming works. But in case of machine learning, what happens is, here we know the input, we know the output, we just give the input and output to the computer. And the computer has to understand the logic between why a certain input is related to a particular output. Now let's take an example of, you're trying to add two numbers, okay? So if I had to take an input, I will take input from user in a variable A, and another input from the user, a variable B, and then I'll write a program that is going to output A plus B, right? So this is how we would do it in traditional programming. In machine learning, what I'll do is, I will give, let's say, 50 samples, okay? 50 samples I've given, in which we have two input datas, right? So once I'll have 5, 5, 2, 3, like that. I have a lot of these numbers. So I have, let's say I have 50 such rows. Each row will have two numbers and the output, okay, and the result. So if I have 5 and 5, the addition is actually 10. then I have 2 and 3, and then I have 5. So I have an entire table with data like this. So I have given the input and I've given the output. Now I tell the program, I give it to the computer. Now the computer is supposed to understand why in the first row when we have input 5 and 5, the output was 10. In another row, we had 2 and 3 as in the first two columns, and the final column had 5. I mean, so if 2 and 3 was my input, the output was 5. If 5 and 5 is my input, then the output was 10. So what is the calculation that we're having between this number, which is resulting in this, right? So this logic of actually doing addition is done by the computer itself. It looks into a lot of samples and tries to develop this understanding, right? So that is what is machine learning. And so I hope you guys have understood the concept and idea behind how usually traditional programs are designed and how machine learning programs are designed. Was this example clear? Should I give another example? Did you guys understand the difference? Yeah, sure. So I'll give another example. Okay, now let's say that we are trying to understand whether a person is trying to. So let's say we want to know whether a person is going to walk or a person is going to run. Okay. Now for us, it is very simple. When you see the person walking, you know this is walking. And when the person is running, you know it is running. Correct? It's very straightforward to us. And you know, you guys have these different apps in your phone that tells you how many steps you have taken. You even have Fitbits that tell you how many steps you have taken, right? So how are all of them actually calculating how many steps you have taken? Correct. Now how is this actually working? Because there is nobody, there is, it's not like it's not like your mobile or the Fitbit has an eye open and checking how many steps you're taking, right? So how are these devices able to understand how many steps you have taken, right? So let's say we had to solve this problem with the traditional programming approach and the machine learning approach. So we'll see how the same problem can be done with both. Okay. So if I was using the traditional programming, we'll try to find out what is the average speed of a person if they are walking. Okay. So now all of this, the Fitbit or Fitbit has a GPS sensor which is constantly monitoring your location. And most of the times, even your phone is always monitoring your location, right? So then again, that is one thing, you can understand the distance that is covered and the time that is taken to cover the distance. So once you know this, you can automatically find out what is the speed, right? So once this information has reached the server, what the server does is that it'll find out what is the speed. It will compare it with the average speed of a human being walking. Okay, let's take for simplicity that may in a minute a person keeps 70 steps. Okay, so he keeps 70 steps in a minute, right? So they'll find out what is the average speed. So we're telling that the average speed is 70 steps per minute, right? This is, let's say, the units that we are using. Now we'll 70 steps, you think one step is, let's say, 1 meter. So 70 steps is 70 meters. So 70 meters per minute. If you're moving in around this range, let's say plus or minus another 5 meters. So you give a flexible range. So if the speed that you have calculated by understanding the distance traveled and the time taken for that, you find out the speed. If the speed comes in this particular range, let's say from 60 to let's say from 55 to 75, right? So some people might walk slowly, some people might walk faster. So I will take such an example. So I'll be like, okay, so much distance. So based on this, I because it falls in this range, the application understands that it is a person walking, and automatically it'll take a approximate number of steps, and it will tell that this many steps you have taken today. So this is how we could do it with traditional programming. Now let's say this, and this is how mostly it is done. Now let's say there is a very much fancier application. This application wants to solve this problem using ML, and they have a lot of data with them. So they want to do it like that, right? So with ML, already in the first example when we have seen, in case of the traditional programming, I just needed one input and a program, I would get the output. But if, for an ML approach, I needed at least 50, 100. The more samples you have, the better it is. I needed so many sample inputs and outputs. Then the program would try to understand. Basically, when you were a kid, when you had to learn that this is a dog or this is a cat, you saw dogs many times, and every time your mother or father told you this is a dog, this is a dog, this is a dog, so it registered in your head that this is a dog. And when you would look at a cat, you would say this is a cat, and you would try to, in your brain, try to understand the difference between dog and a cat, and that's how it came to your head that okay, this is a dog and this is a cat, right? So now that's what we're trying to teach that to the machine as well. That is why machine learning. Yeah. So anyway, so when we're trying to learn, when we're trying to make the machine learn how many steps it's taken, let's say I have videos of a person walking and videos of a person running. Okay, so a lot of these videos I provide as input, right? Let's say I have 1,000 videos of a person walking and 1,000 videos of a person running, and each the videos are again labeled that these videos are walking videos and these videos are running videos. Now once that is done, the machine is supposed to look through all of these videos, okay, and try to understand which videos are classified as walking videos and which videos are classified under running videos. Try to understand why these videos have is come under running and why these videos have come under walking. Differentiate between them. Now, when I give another video to the machine, now that is trying to, from the knowledge that it has gained through these 2,000 examples, it's trying to predict whether this video the person is walking or the person is running, right? So that is how it works in case of machine learning. Is it more clear to you guys on what is the difference between traditional programming and machine learning? Any doubts? That means the logic. Essentially, when you give in out data and the output, so you know this. So what you get is the logic, right? The output can be that for the addition example, when all of that is done, it learns that this is what is addition. So it says the program is to, when a new input is given, it'll automatically be able to predict the output through the program. So that logic is developed on its own. Any other doubts? And also somebody had a doubt between data science versus machine learning, right? So now that we have discussed data science and machine learning, uh, are you able to understand the difference between those two as well? I see only a few replying in the chat. If you guys are having any doubt, you can let me know. If you're not having any doubts, then you can put no in the chat, right? So that I know all of you are listening and that you don't have any doubt. Okay, awesome. Okay, so then now we can move ahead. We can look at some of the common myths that people generally have with these topics. How can machine learning do calculations by its own? Yeah, exactly. This is what we will learn in our course. We'll see how there are various algorithms, various paradigms, various structures on how it will develop its own understanding. The main idea is that it uses concepts of, like I said, we use a lot of linear algebra, we use a lot of statistics, probability, pattern matching. So we use all of these concepts to build those algorithms. Okay, so now we look at some of the common myths that people generally have. Okay, So one thing is that they think that data scientists will be actually replaced by artificial intelligence because I'm sure all of you have heard a little about AI uh, and the buzz about this as well, right? So this is the most common data science myth I can say, and there is a quite possibility that AI can carry out some of the tasks that are tedious and repetitive of a data scientist. Okay, like the data preparation stage or the data cleaning stage. So those things they can probably take care of, but a data scientist will always be required to carry out some of these advanced operations that we have that advanced operations that basically tell the machine what needs to be done, right? So this cannot be taken up by AI just like that, right? There is a drive to automate data science, and people are building more sophisticated algorithms with tendency to eliminate the need for a completely dedicated data scientist, but that this is a very unlikely situation to happen. And as even like the most advanced AI systems that you can think of, they also work with what we tell them to work with, and they require a human guidance. So it will not be possible for AI or machine learning to judge what is right for a business problem and what kind of domain knowledge will help them, right? So and they do not know what trends and prediction mean in the real world context, right? They only think of it as in like it is only it lives in its own bubble. It is only looking at it in terms of numerical values, right? So it is only thinking of it in that way. So all of the predictions, what actual significance or meaning it has to the world, um, that is, AI is machines are not aware of it, and how these things in the real world can benefit the business as a whole in helping taking decision, all of that artificial intelligence will not be able to help. So that is why we will need a data scientist, and the role of a data scientist is here, and it is going to stay, and it's going to demand all of the skills that we just saw, and and presently it's already in its all-time high, right? Already you see that it's I'm sure all of you, even if you're watching random YouTube videos, something with data science, there is an ad that comes in between, right? So it's literally everywhere. And if there was not a requirement for so many skilled people, you wouldn't have had so many advertising about it. When there is a need and expectation for it is when the buzz builds about it, right? Okay, so the next thing is that data science is all about building models. So, as much as I wish to say that this was true, this is not. And this is another common myth, I can say. So, basically, building a machine learning model, right, is one of the small pieces of big data science pipeline, right? So, like I said, we have so many phases in a data scientist role, right? So we have data acquisition, how are we going to collect it, data cleaning, and then we have data preparation, where we're actually getting this data ready for whatever we're going to do further with it, visualize this data, analyze the data, and then finally you have model development, and then deployment. There are so many phases in it, right? So it is not just about building models. In fact, building a machine learning or deep learning model is only about, let's say, a maximum of 25% of the total, in the entire data science pipeline. It's only maximum of 25%. Usually it's around 15 to 20 itself, right? That the total time that we spend on model is just that much. And more than, let's say, around 50 to 60% of the time, it's mostly, the cleaning phase and preparation phase, collection phase. All of these things are more tedious and take a lot more time. Okay. Next, we have that business or the domain knowledge is not so important. So this is a very big myth, and which is why, and then, many aspirants don't really focus on this part because they don't see the importance of it. But having a business or domain knowledge is very, very crucial in data science. Any data scientist, they need to have a good knowledge with respect to the domain in which the domain on which problem they're working. And this is not just with data science, even with other computer science jobs that you have. You need to have an understanding of the domain for which you're developing solutions. If you do not think in their point of view, if you do not understand their pain points, you'll not be able to address it, right? So having business and domain knowledge is very crucial. And this is what actually differentiates an experienced data scientist and with the data scientist who has just started their career. This is the major difference. And the domain knowledge, you can uncover and discover so many important things that a world class data scientist will not be able to do, right? So in each and every step of the pipeline, you have to have domain knowledge. For example, let's say you can discover a good data featureization and visualization. All of that will be so much better when you have knowledge about the data. And it is easier for you to know what is the business objective. And when you have the knowledge of the domain, understanding the business objective properly will be much better, right? And because once you understand the objective is when you'll be able to manipulate the data you have, present the necessary information, because you have a lot of data that is collected, but nobody is having the patience to look through all of this data. So you're basically summarizing all of this and doing, unless you know what is the end goal, how will you know how to summarize it towards it, right? So that is why the domain knowledge plays a very crucial role. Okay, the next thing is learning a tool is most important in data science. Now, although like this is a prerequisite, right? But mastering data science is not just about learning a fancy tool or language. So you're not just a programmer here, right? So through the tools and languages, it can help you in many ways, but you require analytical skills. You need to have understanding about the business problem. You need to you need to have good understanding of statistics and apply that. And then also the concepts of ML and AI. So all of that is required in solving business problems. So a data scientist should basically have very good problem solving skills and know when and where which tool to apply, right? So there are a lot of things that is available to us, but when what has to be used, that is what we actually do. That is where the intelligence lies. Also, we should have a we should have a crucial ability on how you're going to communicate this result um, to whoever the stakeholders are, right? So it could be the clients or the company you work for itself, right? And it should be presented in a way that it's very simple and intuitive to them. Okay, the last one is that data science is just the hype. So a lot of people debate about this, and that it is just a hype and it won't last for so long. But the fact is that data science has become one of the most important aspects of determining the success of any organization, irrespective of which domain they are in, right? Because every domain, I said, it needs data science. According to I think IBM, we are generating data at the rate of uh, you know 2 quintillion bytes per day, which is basically 90% of the world's data that had been created 2 years ago. So 90% of the data that was created 2 years ago, we are generating that much in a single day. So imagine how much more data has been generating now. And with all of this data, if we do not use it to its maximum potential, then all of this is a complete waste. So with all of this that is being generated, with so many diverse sources of data also, right? It is not just from companies and offices. In our day-to-day life itself, we are generating so much data. So it's very important for us, and that's what data science helps us in doing, to structure, analyze the data, and find out what are the hidden patterns and and help us solve basically crucial real world problems. Okay, next we'll try to understand the different types of machine learning that is there. Okay, so we have three different types of machine learning. Since we have understood what ML is, what data science is, we have got a little idea about statistics and data preparation as well, right? So with all of this, we also saw that we'll be learning some classification algorithms, right? So first of all, we'll try to understand where does this classification fit into in the structure of ML, right? So in ML, we basically have three types of learning. One is called the supervised learning, and then we have unsupervised learning, and finally we have reinforcement learning, right? So these are the three things. Now, under each of them, again, there are multiple subsections that do exist. Okay, so till now, do we have any doubts? If we are having any doubts, we'll address that, and then we'll start off with supervised learning. So if you're having any doubts, you ask the doubt. Otherwise, you put no in the chat. Okay, awesome. So we will start with supervised learning then. Okay. So in case of supervised learning, basically, we have an input of raw data that is there, and there is a supervisor, which is basically a person who is grouping each of the training data set with the desired output, right? So in this type of learning is what we had discussed all this time, right? And why we discussed about this all this time was because the major algorithms that are built and the ones that are extensively used these days are all supervised learning itself, right? So most of the algorithms, most of the ideologies are built with supervised learning itself. Maximum ones that are deployed are based on this idea. The other two methods that are there, I mean, the other two types that are there, which is unsupervised and reinforcement, they are the ones that are having a lot more research going on than places that it has been implemented in. Not that it has not been implemented. There are many places that have been that have algorithms with unsupervised learning and reinforcement that have been implemented. But supervised is the one that has having so many more algorithms. So if you see, if supervised learning has 20-30 algorithms, in case of unsupervised learning, you have like 5-6 algorithms up top, right? And in reinforcement, it's even less. You have only around 2 or 3 algorithms that are, proved and basically have performed well. So most of the times when we're talking about machine learning, most of the times people are actually talking about supervised learning, right? I mean, the general crowd, I mean. So here, basically, we have a lot of input raw data that is there, and all of these data are labeled. So who is actually labeling all of this data? It is the supervisor. So now let's see this data that is there here. If this was our raw data, it's basically, you have three different types of shapes here. So we have red triangles, and then we have these purple squares, and then we have green circles. So our input data is a mixture of a lot of these samples. Okay. So let's say their image data only you think. Okay. So we have a lot of images of triangles, a lot of images of circles, and a lot of images of squares. So I have this, mixture. And what has actually happened here is I know that each image, right? So like, let's say the triangle image belongs to the red class, and the square image belongs to the purple class, and the circle image belongs to the green class, right? So we're trying to predict basically which color the object is having. Okay. So it could be the color, or it could be the shape itself, anything. And it doesn't even have to be the shape. Okay. It can be any training sample that belongs to a particular class. Okay. Which is just denoted with this. Okay. So maybe we are trying to differentiate between a dog, a cat, and a dog, a cat, and a fish. Okay, so we're trying to differentiate between these three things. And we're having samples of all of them. I'm representing dogs with a triangle mark because I cannot draw so many pictures of dogs. I mean, I cannot put so many pictures of dog here. So I'm just representing in that way. And I'm representing cats as circles and I'm representing fishes as squares, right? So it is basically any problem you can imagine, you can think of where you have a particular output to it, right? So you have collected this data. In all of the rows that you have, you'll have to assign one thing as your output and the remaining rows are going to be your input. So let's say, now let's take this simpler one itself that we are seeing. So we'll think that we want to classify according to the color. Okay, so we have all of these samples. A supervisor has decided and marked each of the sample with the desired output, correct? So once this is done, an appropriate algorithm is chosen based on the input type and the supervisor, okay? And and also there is no hard and fast rule on which algorithm can be selected, okay? There are various algorithms that do exist. Like I said, in case of supervised learning itself, we have 15 to 20, even 30 different algorithms that are there, variations of algorithms. And all of these algorithms work in a different way. And one more thing that we should know is for an effective machine learning algorithm to work, there are many important factors. One factor is the abundance of data that you have, because there will be so many scenarios that can exist, and they can, and each of these scenarios should have sufficient examples, correct? So we need to have extensively a lot of data. There is also this hypothesis that has been proven that if you're having a really good data, right? So if the data is really rich, you have sufficient samples for all type of scenarios that may occur, any algorithm, any supervised algorithm or even unsupervised algorithm, basically any algorithm that you pick will give you a perfectly correct output, right? So if your data is really good and clean and rich, then you don't really have to break your head about the algorithm. I mean, you don't have to break your head about which algorithm to use. You have to think about the algorithm. You have to, the algorithm has to be designed smartly. But which algorithm should I use? Which algorithm will perform better? This confusion will not be there. But the thing is, in real life scenario, we will never have data that is that rich, good, and perfect, right? So you cannot have perfect data, which is why different algorithms will perform to different extents on the same data set. So let's say now regression is one type of linear regression is one type of an algorithm. We also have support vector machines. Now these are two different algorithms. The same data set, I use both of these algorithms. One algorithm may give me an efficiency of 90%, the other might give 95%, correct? It is the same data set. And it's not that the one algorithm is better than the other, because in another data set, the opposite algorithm might perform better. So there is no hard and fast rule on which algorithm is better or which algorithm, uh, you know, gives us the best efficiency. It always depends on the data. And so basically, the data was really good. Any algorithm you would have used, you would have got 100% efficiency. Okay. Anyway, so we need to pick one algorithm looking at the input data that is there, different type of data. Certain algorithms tend to perform better on certain types of data, right? So maybe support vector machine performs better with image data, or something else performs better with linear regression. You don't know. So there might be some algorithms like that. So based on that, you will pick a particular algorithm, and whatever the processing of the algorithm is done. Okay, so the processing depends on the type of algorithm that is picked, and it is done on the input data, and that results in the output. So now this entire bundle of raw data is divided according to their output, and that is the processing time. The computer has basically learned how to do that based on understanding some patterns between them. So if I say some 2-3 samples, all of them have been classified as red color, you'll try to think why only these things have been classified as red. So you look at the similarities between them, And also at the same time, I look at the samples which are classified, let's say purple, and you compare a red sample with a purple sample and see how they are really different from each other. So you see similar things, understand what's common and learn, and you see things that are different and understand what is making them different, and understand that when you have samples like this, it should not be classified under my section, right? So based on such pattern matching and understanding, you can classify data. So this is essentially how supervised learning algorithms work. Now, in case of unsupervised learning, you again have the same input raw data that is there, okay? But you do not know what is the output, as in this huge set of data is there, but I don't know that this data is basically having three types of shapes or it is having three different colors. I am not aware of this, okay? I just have a lot of data and I want to know whether this data is of any relevance. That is all my question is, okay? How many groups of people might be there inside this? I don't know, okay? So there is no human being, that a human being or a supervisor basically, who's telling you what the correct answer is. In case of supervised learning, you knew what was the correct answer and you were trying to understand why a question is related to that answer, okay? But in case of unsupervised learning, you just have data, you don't know what the output is, okay? So you're trying to interpret the data basically. You pick an algorithm and do the processing related to the algorithm, and you just push things into different subsections, right? You just push it into different clusters. So here we have something called as clusters. I will tell you what are the broad differentiations or subsets inside supervised also and inside unsupervised also. Okay, so one thing is a clustering algorithm, right? So inside unsupervised algorithms, we have something called as clustering algorithms, wherein you're grouping related objects together. You're forming different groups here, okay? And this, there is no right or wrong way to do it. The algorithm just process it, sees again what are common between things, what is different between something, and just pushes it up, okay? Here it doesn't know that this has to be pushed to this particular value, as in I'm not aware that this thing should be pushed to triangle, or this should be pushed to circle, or this should be pushed to square. I'm looking that triangle and square, they look different, so I'll keep them separately. Circle and square look different, so I'll keep them separately. Circle and triangle look different, so I'll keep them separately. If I get another sample which is similar to a circle, I'll group it with the circle because they look alike, okay? So that is how it is doing in case of unsupervised learning. Now you finally get the outputs. Once you get the output, the human being is now involved in the end stage, right? So once these groupings are done with all of these clusters that are formed, the human tries to understand why these clusters are formed, okay? And based on that, it will it will look into the data that is grouped, these data are grouped together, and try to understand why these data points are closer to each other, why these data points are closer to each other. So this type of understanding is developed in a later stage, okay? In case of supervised learning, I missed out telling two subsections that, is my screen visible to all of you? Okay. Just wanted to confirm, yeah. So in case of supervised learning, there was one thing that I missed telling you guys about, which is there are two subsections, like how in case of machine learning, we have supervised, unsupervised, and reinforcement learning. Under supervised learning, we again have two more subsections. One is regression problem and the other is classification problem. So in case of regression problem, our output is basically a continuous value and it is always a numerical value, okay? So our output is always a numerical value and it is a continuous value, as in there's no distinct numbers that is there. Let's say you're trying to predict what is the price of a house, right? You're trying to predict what is the selling price of a house. So maybe your table is having data of number of rooms and what is the built-in area, as in what is the area of the plot, and what are the amenities that are there in the house, right? So you can have, and what is the location of your house. So you have various such parameters that are your input parameters, and your output is the selling price of your house, right? So let's say 30 lakhs, right? So maybe the prediction is 30 lakhs. Now you can have 30 lakhs, 31 lakhs, or you can have 30 lakh 55,512, right? So you can have, it can be any continuous value between a particular range. Okay, so let's say, and the range is also not restricted, right? For us it will make sense to not have any negative values, but that is also possible in case of selling price. Maybe there is no value, you can maybe think of it that it starts from zero, right? So from zero to infinity, this is our range. But if you want to be a little more particular, maybe we can say from 10 lakhs to, let's say, 100 crores. Okay, so this is the range that we will stick to. Compared to 0 to infinity, this is a much smaller range according to this problem. So it can be literally any value between them. And it's not even that decimals are also included. So it can be 10, 10.5, 10.25, 10.2225. So there are there's a very vast range of outputs that are possible. You have continuous values, right? So such problems are classified under regression. Okay. Some other problems can be classified under classification. Here you don't have continuous value as your output, instead you have categorical values. Okay, so like you're trying to understand whether it's a dog, whether it's a cat, or like we saw over here, there are three distinct categories, right? It's either a triangle or a circle or a square, right? There is no in between, you have only these things, right? You have clear distinction, and you're only having three different classes. Three options are there, you have to pick one of them. So this thing is called as a classification problem. So the example that we discussed was classification. In case of unsupervised learning, we have something called as the clustering problem, which is again basically it's grouping related things together. Since we've used the word classification in supervised learning, right? Again, here it's categorical values itself. So clustering is the word that is used in case of unsupervised learning. Now, finally, we have reinforcement learning. Do you guys have any doubts till this point? Okay, the difference between supervised, unsupervised, and reinforcement. Which one is more efficient? So supervised and unsupervised, I already told you what the difference is. In case of supervised, you already know what the output is. It's just that you're trying to find out what is the relationship between the input and output. In case of unsupervised learning, you do not know what the output is. You have a lot of data and you want to make sense out of this data. An example of unsupervised learning is, you know how you get ads related to a particular thing, or let's say you have bought a plant, then you'll probably get advertisements to buy fertilizer as well. Maybe I should give you something more relative to you. Maybe you've bought pencil, so they'll also ask you to buy a sharpener or an eraser, right? So how do they understand that you buying pencil might also want you to buy sharpener? Or maybe you read certain books, you read books of a certain author, they might start suggesting you books of other authors who write books of similar genres. So how does this happen? All of these market analysis, this is called market segmentation. This is done with clustering algorithms, right? So here what happens is that it's not like you will buy it. There is no right or wrong answer here. I'm just thinking that you bought pencil, you might want to buy an eraser. And why am I thinking that you'll buy an eraser? Because another person who bought a pencil had bought an eraser also. So I'm thinking you also might buy. Okay, there is no right or wrong in this. So what happens here is what Amazon or Flipkart, what all of them do in the back end is they group all of these, they use clustering algorithms basically. And based on the type of products you're buying, the algorithm pushes you into some group. Okay, so some other person in the group you belong to might buy something else when they had bought what you bought. So they will give you advertisements on that, right? So there's no right or wrong answer. It's just that you're trying to you're just trying your luck out. So that is unsupervised learning, and this is just one example. It one example of clustering, but it is used in many more places as well. Now reinforcement will look into it now. Which one is more efficient? There is, yeah, like you cannot compare supervised learning and unsupervised learning. Okay, now in case you're having data which you don't have the outputs for them, right? When you don't have the outputs for them, you cannot give it to supervised algorithms. You have to give it to unsupervised algorithms. And if you're having labeled data, it would make sense to give to supervised algorithms itself, right? So basically there is no concept of efficiency between them. You can compare for efficiency inside supervised learning. Inside supervised learning, what is the efficiency a linear regression algorithm will give, or support vector machine will give, or logistic regression will give? You can compare inside, internally, but not externally. And also efficiency is, um, it's a word that you cannot use that easily in case of this, right? Okay, so who will play the role of a supervisor in case of supervised learning? Yeah, so supervisor is any human being. Okay, so it's not the programmer. When you're collecting data, you're labeling each of the data to its output. This happens in the data collection stage itself. Okay, so that person is only the supervisor. I mean, supervisor is the name for, um, supervisor is any person who's guiding on how the data collection needs to be done. So this can be fulfilled by any human being. Any other doubts? We'll look into what reinforcement learning is, and then you can see. And basically, supervised, unsupervised, and reinforcement learning are, all of them are used in totally different scenarios. You can use for the same scenario algorithms from different models, but different types, but mostly it's always used in different fields. So there is no comparison of efficiency between them. Like you'll not compare efficiency of a carpenter with the efficiency of a blacksmith, or efficiency of a carpenter with an efficiency of a farmer. They're two unrelated things. Do we have any other doubts? Can we move on to reinforcement learning? Yes or no? Okay. So now we'll go to reinforcement learning. So the approach behind reinforcement learning is completely different from both supervised and unsupervised. In case of supervised, you had labeled data. In case of unsupervised, you do not have any labels with your data. In case of reinforcement learning, the ideology behind it is completely different. So here you're basically trying to teach a person through experience, right? So you're letting them explore all the options that are available, and then you try to make them eventually understand what action they should take in which scenario. Okay, so this is more similar to when you're trying to, let's say, you're trying to teach a kid to do something, right? So this is more close to that. When they do something correct, you give them a reward, right? You like appreciate them, or you give them a chocolate, or you give them a treat that they like. And if they do something wrong, then you discourage that, and you know some type of punishment might also be given. So whatever, you do not encourage that action, correct? Or and or that person also learns that the result of that action is not something favorable, so they reduce doing that, right? So maybe in the beginning they do not know what is the right thing and what is the wrong thing, so they're just trying out different scenarios. And by seeing the result of trying out that method, they understand whether it's a good choice or a bad choice, right? And based on that, when they're taking decision next time, they'll be more informed of the decision that they're taking. correct? The first time, uh, the first time maybe you slap somebody, you take the action, and then you see what is the result from that action. So because you slapped somebody, your teacher might come and scold you, right? So, and they tell you that it's not the right thing and all of that. So once you've done that, you understand that this is not a favorable, I've not got a favorable response from this, this is something I should not have done. And if you get a gift for somebody and the person is really happy and they appreciate it, so because of that you understand that you've got a favorable outcome from this, so this is something that the person has liked, so you can do more of this, right? So there is an environment, and this agent is the person, I mean is the machine, who's trying to perform an action and learn from the action based on the response in the environment. Okay, so that is essentially this loop. So we have an agent, it selects an algorithm, right? The algorithm helps us pick the best action of the available options. Okay, and that action is performed and the environment changes, that is it goes to another state, and there you receive a reward. This reward can be a positive reward or a negative reward. Based on that, you change the state of the agent. Okay. So let's try to understand this with an example. Let's say you're trying to teach a robot how to walk. Okay. So you have not given any steps or any options or any what do you say? You have not given an algorithm, right? That, oh, first you lift your left leg and then move it front and keep it down. Then you lift your right leg, move it front, keep it down. You have not given steps like this that it has to iteratively do. It has to understand this on its own. Okay. So basically, what will happen is maybe the robot will fall multiple times, but eventually it will learn how to walk. This is how children also learn how to walk when they're younger, right? So now, now there, what are the actions that we have in this stage, right? With this example, we'll try to understand each of these things. So we have different actions. Okay, so maybe if the first action is lift my left leg, the next action is lift my right leg, and then I have another action which is move the leg forward, and then you have another action which is put down your left leg, and the other option is put down your right leg. So let's say for simply, there are many more actions that are possible. For simplicity, let's just say that these are the 5 actions that we have. Okay, 5 options that we have for actions. Now there is some selection algorithm. This algorithm is what is constantly being improved, right? So first, because I don't know what is the reward or associated with each of them, I will randomly pick an action. Okay. So maybe first I'll pick that I need to move my leg forward. I mean, I'll pick the thing that I have to lift my left leg. Okay. So I'll pick my left leg, and then this takes me to another environment that I am in, and it is a positive change towards me learning to walk, right? I need to lift my leg first to walk, so I get a positive reward of, let's say I get plus 5 points. Okay, and this has taken me to the new state. Next, now again in the new scenario, I need to again pick an action. Now in this place, if let's say the previous time, in the previous state, picking my left leg up gave me a positive 5 reward, right? So let's say I pick my left leg again. My leg is already up, and on top of it, I'm lifting it even more. So the robot will lose its balance and fall down, right? So the same action may not be favorable in all the scenarios, right? In every state that you are in, the same action will not take you forward. So you need to understand, based on the present state, which action is better, right? So now again it's going to restart, right? The robot will start learning from first. The goal is that it should be able to take 10 steps. Okay, if it's able to take 10 steps, then we say that it is, at that point you can move out of the loop, and you can move to the complete stage, right? It's like one game that we're playing. So again, we're going to do restart. So again, it will start from, and all the knowledge that it has gained will still be in its head. So it had picked up its left leg first. Okay. So maybe it will pick up the same move again, because last time it got a reward. It'll pick up that it got a positive reward. So it has moved to the next state. Now my left leg is up. Next, I need to decide whether I have to put my left leg down, or I should lift my right leg, or should I put my right leg down, or should I move ahead? Okay, move my leg ahead. So I have different options. Now maybe I'll try to say move my leg ahead. So my left leg has been lifted up and now it's moved ahead. Right. So I get, now this is a positive approach, right? So again, I'll get a positive reward for this. So in the second state, now we have learned that after lifting my left leg in this new scenario, lifting my left leg again is not the right thing. So moving forward is a better option. I've got a better reward. And then I'll move to the next state. In this state that I am, I need to again select from the actions that are available whether I should lift my right leg or put my left leg down or put my right leg down or move forward again. So let's say at this point that the robot decides to lift its right leg also. The left leg is already up and forward. It lifts its right leg as well. So it will definitely fall down, right? So this thing is iteratively done again and again and again until it figures out in every state, every type of state that can occur, what is the best move that you can take. Right? So based on that, you'll take decisions. So this is an iterative loop until the robot is able to take 10 steps without making any mistake. In case it makes a mistake, it starts from step one again. Okay, it goes back to the state zero. So it'll keep doing this iteratively again and again and again. And in the beginning, most of the time, the actions are picked randomly until we understand which action is the best, right? So sometimes there can be more than one action that might take you to a positive state, but some action might take you to a really good state and some to a medium state. So the one that takes you to a really good state will have higher reward points, maybe plus 10 for something, and the other will have plus 5. Something else will have minus 2. So like that, on each stage it tries to understand what is the most suitable action and takes a decision accordingly, and that's how we get that's how it learns. So this is the approach the machine uses in learning to do a particular task. So this is how reinforcement learning works. Now you guys might have guessed how this is really different from supervised learning or unsupervised learning. So I hope all of you, it's clear to all of you on how we have different types of machine learning, right? We have supervised, unsupervised, and reinforcement. In case of supervised, we have classification and regression. And in case of unsupervised, we have clustering. Okay. So the next thing that we have to do is get our laptops ready for the sessions from tomorrow, right? We will be working with Python, Python programming language. So you can use any IDE of your choice. So you can use either Anaconda, Jupyter Notebook, or Google Colabs, whatever you are more comfortable with. Is there anybody in this group who is having an Ubuntu laptop? If you're having a Linux or Unix based operating system in your laptop, please raise your hand. Anybody of that sort? Okay, so I think all of you are using Windows operating system itself, right? Any other operating system anybody is using? Okay, so if all of you are using Windows operating system itself, then there is no problem at all. You can use any of these IDEs. Whether you want to use Anaconda or a Jupyter Notebook directly is your choice. Okay, so two of you are using Mac laptop, is it? Okay. Then I suggest the students who are using Mac, if you can install Anaconda or Jupyter. I'm sure Anaconda in their page, they also have an extension to download for Mac. So you can download that, or like all of you, irrespective of which operating system you're using, all of you can use Google Colapse. Okay. So now I want all of you to open a new tab in your laptops and open Google. I'll share my screen. Here you need to search for Google Collabs. Okay, once you search this, the first link that you'll have is collab.research.google.com. So you need to click on this. And once you click on this, basically what will happen if this is your first time that you're opening Google Collaboratory, then you'll probably have to agree to some conditions, some terms and conditions of using it, and you'll have to accept. I'm sure all of you have a Gmail-based account, so you'll have to link that to it, and that will once you agree to all of that, it'll open a page that looks something like this that says "Welcome to Collaboratory." This is your Google Collaboratory environment. Once you reach this page, please put a message done in the group chat. Since I've been using Google Colab multiple times earlier, I did not have to agree to all of that. We are having 45 people in today's session, so I want all of you to reply that you have done this, because irrespective of whichever operating system you're working on, I suggest that all of you use Google Collaboratory itself. So I want all of you to do this, because from tomorrow we will directly start with writing Python programs, and we will not be going through this step again. So everybody please reply in the chat once you have completed this and you've reached Welcome Collaboratory stage. Okay, so I think most of you have done it. Awesome. So here under File, you can click on New Notebook. This will open another notebook. This is your Welcome to Collaboratory notebook. You go to File and click on New Notebook. That will open an environment that looks something like this. Now, once you reach this, I want you to type print, open parenthesis, and hello. And once you type this, there is this play button that is there, right? I want to click on that. Now, once you do that, you'll get a cell below, which is basically giving you the output of hello. Once you get this output, I want you to put a message in the group chat saying done. Okay, so once you complete this, this is the major task that we have to complete by today. And if any of you, the advantage of using a Google Colab is that you don't have to install Python or set up your environment or do any of those things. You can just directly work and start writing your code, focus on the main thing, okay? And irrespective of the configuration of your system, you'll be able to run programs that even if you need, GPUs or anything, you can even use the Google GPU that's available and run your programs, right? So that is the advantage of using Google Colab, which is why I want all of you to use that. But in case you also, only drawback is that you'll have to have an internet connection to do this. So which is okay during class, may not be okay all the time. So if you guys want to work offline as well, then you can install either Anaconda or Jupyter Notebook, whatever you prefer. You can download and install it on your system and be ready tomorrow. In case you get stuck in any place during the installation, you can let me know in tomorrow's class. We'll look into it and then we'll continue. If you're having any other doubts regarding what we have discussed today, you can put it in the chat section. Otherwise, we are done with today's session. Thank you, everybody, for attending.